Hey guys, so this is your sine wave lesson. So I'm going to take it slow. So this video is going to be kind of long. I want to make sure that I don't go too fast, and there will be points where you're going to want to pause to copy something down, and feel free to pause and rewind and go back on something that I have said, just to make sure that you're fully understanding. The sine wave and cosine wave are not hard. It's just they involve a lot of things. But everything that we've learned so far kind of ties in to how to graph the sine wave, how to graph the cosine wave. So sine wave will be today. The next lesson will be cosine. And then the lesson after that will be all the rest, because all the rest are pretty easy after these two are set. So please make sure that you have a piece of graph paper. Like I have graph paper. I'm probably going to need a couple pieces. If you don't have graph paper, no big deal. You can use lined paper, or get a piece of just blank computer paper. But you'll definitely want a ruler so that you could draw straight lines. Okay. All right. So, speaking of which, I need my ruler. So anyways, today is all about the sine wave. And the sine wave we're going to see, it's going to go up, down, up, down, up, down. It's going to look like this, but on this graph over here. But before we get into that, I want to start with a warm-up. So if I were to normally teach this lesson in person in our classroom, I would start with a warm-up like this. I would probably do something like this on quizzes, because I like using quizzes, as you guys know. So for this one, we're given 2x minus 1/4, and we need to factor out a 2. So when we factor out something, we put that number that we're factoring out in front of parentheses, and then in the parentheses, it's whatever is left. And when we factor something out, we're dividing that number out. So we're dividing out a 2. So 2x divided by 2 is x. And now I have to do negative 1/4 divided by 2. So I know it's going to be negative. Well, negative 1/4 divided by 2, remember, dividing fractions is easy as pie. You flip the second and multiply. So I'm really taking 1/4 and dividing by 2, right? So that means that I'm really taking 1/4 and multiplying by the reciprocal of 2, which is 1/2. So a fourth times a half is 1/8. Okay, so this is what I would get when I factor out a 2 from 2x minus a fourth. So let's try the other one. So I am going to go over the second one, but how about you guys press pause, those of you that care to make sure that you know how to do it, and try it on your own. And then once you've tried it, press play again, and then see that we got the same answer. So I'll give you guys a moment for that. Okay, you might have pressed pause, you might not have, but that's okay. I'm still going to do it anyway. Hey, that rhymed. So on number 2, we have 3x minus pi over 2, and I'm going to factor out a 3. So I'm going to divide out a 3, basically. So 3x divided by 3 is x. And then I have negative pi over 2 divided by 3. Okay, well, I know it's negative divided by positive, so it's negative. Okay, and then I'm taking basically pi over 2, and I'm dividing by 3, so dividing fractions easy as pie. Flip the second and multiply. The reciprocal of 3 is 1/3. So when I multiply straight across, that will be pi over 6. And a good way to check these is to distribute the number back in. 3 times x is 3x. 3 times negative pi over 6 is negative 3 pi over 6. The 3 goes into 6 twice, so I would get negative pi over 2, which was the original. So you can always multiply it back in to check and make sure that you're doing it right. Okay, so the reason why we have this warm-up is like a math 1 type of a thing. Well, the reason why we have it is because we need this skill for some of the problems that we're going to do. So you're going to see what I mean by that. All right. Okay, so back to the sine wave. So our parent function, because remember, you know, quadratics, cubics, quartics, all those have a parent function. And our parent function is y equals sine x. It's basically the version that has the bare bones minimum. And we need to figure out what this graph looks like. And we know it's related to the unit circle. So on our unit circle, we have some things. I'm just going to use radians because we usually use radians when we're graphing sine, cosine, tangent, all those. Okay, so on our unit circle, we know that we start at 0 radians, and then working our way around counterclockwise, we have pi over 2, which is 90 degrees, and then we have pi, and then we have 3 pi over 2, and then a full circle takes me back to 0, which is now 2 pi after you've made a full rotation. Okay, also what we know is the coordinates at these, what I call the 4 corners of our circle. We know that this is the coordinate 1, 0, because the unit circle is 1 unit, so its radius is 1. This is the coordinate 0, 1. This is the coordinate -1, 0. And then this one is 0, -1. Our 4 corners, so easy to remember, okay? All right, so we're gonna be using that because we're graphing on a coordinate grid. So we need coordinates in order to graph. So what we're gonna plug in for X in our T chart, because this is, oh, let me use a different color. These are our X values, these are our Y values, and X is going to be in radians, okay? So the radians that we're gonna be plugging in are from our unit circle. So let's just start from 0. Go 0. We're going to plug in a pi over 2. We're going to plug in pi, 3 pi over 2, 2 pi, making it all the way around. Well, that's only the positive stuff. We also have negative things that we could plug in. So let's start from 0, but go negative now. So if I go negative, that would be negative pi over 2 to negative pi, to negative 3 pi over 2, to a full circle in the clockwise direction, negative 2 pi. Okay, so we are going to plug those in. All right, so when the radian is 0 degrees, okay, what is the Y value? Well, the Y value is 0. Okay. When we're at pi over 2, what is the Y value? Well, the Y value is 1. When we're at pi, what is the Y value? The Y value is 0. At 3 pi over 2, the Y value is -1. At 2 pi, the Y value is 0. So you guys see the pattern going on here? Now let's go in the reverse direction, clockwise. So at negative pi over 2, the Y value is -1. At negative pi, the Y value is 0. At negative 3 pi over 2, the Y value is 1. And at negative 2 pi, the Y value is 0. So 1s and 0s, okay? So you might be thinking, if you're a computer nerd, binary code. And the only reason why I know that is because I had to take a C++ course in college for my math degree. And you had to know a little bit about some binary code. And that was a really rough class for me because I'm not that smart when it comes to computers. I can hold my own, but not the greatest at it. Anyways, so now let's go ahead and graph what we have on here. So let's get our graph set up. Now for our x-axis, we're not going to have 1, 2, 3, 4, 5, 6. We are going to have these radian values, some on the negative side of the x, some on the positive side of the x, okay? And they always go in that order. So I'm going to have, I'll start with the positive. I'm going to have pi over 2, and then pi, 3 pi over 2, and then 2 pi. I'm trying to space them out as equally as I can by just eyeballing it, okay? It doesn't need to be perfect. On the other side, I'm going to have the same thing, but negative. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay. Our y-axis is obviously just going to be dealing with zeros, ones, and negative ones. So the y-axis is the only thing that we count by actual numbers. But I'm going to go up to 2. Top and bottom, just because, oops, these are negative. Just because you need to see that there will be other numbers besides just a 1 on there, okay? All right, so here's our function. And let's go ahead and start plotting these points. What color do I want to use? I think I want to use my pink pen. I like pink. Okay, so the first coordinate is 0, 0. That's easy. We all know that one, origin. And then the next one is pi over 2, 1. So pi over 2, 1, right here. Then pi, 0. Then 3 pi over 2, negative 1. So now I'm down below over here. And then 2 pi, 0. Okay, now let's look on the negative side. We have negative pi over 2, negative 1. Then negative pi, 0. So we're back up to the x-axis. And then negative 3 pi over 2, 1. And then negative 2 pi, 0. Okay, so look at what we have here. It goes up, down, down, up, down, down. Oops, I messed up, but that's okay. My pen slipped right there. But anyways, this is our function. So what's cool about circular functions, because the sine wave is a circular function, circular functions keep repeating. Circular function, it keeps repeating. Okay, so what happens is, and let me switch colors here. Our typical start is normally at the origin at 0. So this is where we would normally start. And our stop is normally at 2 pi. Okay. So this distance from 0 to 2 pi, this little wave right here, this is considered one cycle of our sine wave, okay? And pi would be considered halfway. Okay. There's some other things that we're going to be highlighting on that graph, but we need to get to those definitions, okay? So we just graphed the sine wave. If you want to freak out your parents, be like, hey, Mom, look what I just graphed. They'll be like, what? Now, parents complain all the time about how the math that we do is so beyond them, but I get it. A lot of this stuff, the only reason why I know how to do it is because I got to teach it to you guys, because when you don't use it, you lose it, that's for sure. If anything, even if you're not ever going to use this math again, this applies to a lot of things. There's sound waves, there's, you know, the waves that are produced from our signals to our phones, like all of that is trig. Anything that has to do with any type of wave, that is trig, and that is involved in a lot of different fields. So who knows, you might need to use this someday. Even if you don't, being able to process and think logically through a problem and remember things and apply them, it not only shows your work ethic, but it also shows your ability to think through a problem, even if it's a math problem, okay? So there you go. All right, so we have some important properties here that we're gonna be looking at. And the first thing that we're gonna look at is what I just highlighted in pink here, the standard form. Y equals A sine B of x minus c plus d. So there's a lot of things in there. We have A, B, C, and D that we don't know what those things do. So you have to think of like a quadratic. Remember vertex form, or excuse me, standard form. I'm gonna use vertex form. So if you remember a quadratic, so say you had y equals 5x minus 2 squared plus 7. What this would mean is that this would be your A value, because in standard or in vertex form, that would be AX minus H quantity squared plus K. So remember the A, that is your amplitude, so that 5 would be a vertical stretch. This minus 2 means we're shifted to the right 2, and this plus 7 means we were shifted up 7. So we have a standard form for sine that works the same way. Okay, so the first thing we're going to look at is the amplitude. Amplitude is the absolute value of a, so even if a is negative, we don't care about that because distance is always positive. This is the distance. The graph goes above and below the axis. So this is also referred to as the midline. So let's identify the midline on our graph up here, our parent function graph. So the midline is, it says it's the a value. Well, in this one, there is no a value, so that means that it's a 1. If it were 0, then it would be y equals 0. So it's obviously a 1. There's a 1 in front of that sign. So that means that it's going up 1 unit above the x-axis and down 1 unit above the x-axis. So the midline here is the x-axis. Just going to highlight that. And I'm also going to draw a little arrow and be like, that's the midline. Okay. All right. Next, we have the period. Period is 2 pi over b. So the b value is the number in front of the parentheses there. So that's how we find the period. And this is, oops, sorry, I didn't mean to hit that. This is how long it takes to complete one cycle. Okay. All right, the next thing is the phase shift. Phase shift is c. So just like in the parentheses in a quadratic, you know how that was our shift left or right? This is also our shift left or right. We call that in with trig a phase shift. So this is our movement to the left or to the right. Okay, so left or right translation. Okay, and then we also have vertical shifts with these as well. So, oops, I'm not out of ink. Vertical shift means we're going up or down. All right, and that's the D value. So an up or down translation. So now we know what all the pieces of this puzzle do and how they fit together. Okay, so when graphing, there are 2 big things that we've got to look at. First of all, our normal start. Okay, that's where you take the b times x minus c and you set it equal to 0. This is a normal start. Okay, so what you do is you set b times x minus c equal to 0 and you solve for x. You get x equals something. Okay, whatever that x equals, that is where it starts now. Okay. For our stop, sorry, I'm like getting all tongue-tied. For our stop, you set the b times x minus c equal to 2 pi. That is our normal stop on the parent graph. And you do the same thing. You set b times x minus c equal to 2 pi. You solve for x, you get x equals something, and that is where you end your cycle, okay? So what this does is, let me write in a darker pen. This will take care of where we start. Making sure this all fits in here. Where we start. Oops. Start, it wasn't supposed to be a period. And stop the graph and how to label the axis. And the axis I'm talking about is the x-axis. Okay. All right, so if I pull it out there, you can see the whole thing in case you need that. All right, and so now let's get down to it. We are going to graph. So, oops, on my second page are the examples. I'm going to do some of the groundwork here, but I'm actually going to graph each of these on the graph paper so it looks nice and pretty. Okay, so I am going to start with this. All right. So, and I do recommend grabbing a pencil. Like, I'm gonna borrow my son's pencil that was over here, because we're gonna be working on some things, and it's nice to have a pencil to do it in, because with a pencil, you have more control. You can write smaller and neater, and sometimes a pen, you have to write a little bit bigger. So, so yeah, these aren't that bad, but they do require a lot of elbow grease. So this really shows how hard of a worker can you be. Can you be that hard worker, that valued citizen in society? Let's find out. All right, so we're going to determine the equation in standard form, amplitude, period, phase shift, vertical shift, and then we're going to graph it. Okay, so we have this equation, y equals 1/2 sine of x minus pi over 3. So there's a list that you're going to need to make every single time you do these problems. So I'm going to start with, we're going to need to find the amplitude. Okay, so amp. We're also going to need to find the period. We're going to need to find increments, which was not on the last page, but these are easy to find. I'll show you how to do that. And then we have our phase shift. So I'm going to put PH for phase and then SH for shift. And I'm out of room there. So now, and then we also need to identify our vertical shift. So I'm going to put VSH for vertical shift. You know me and my abbreviations. That's how I roll. Okay. All right. So there's that part. So let's start by identifying these things. Okay. So what color do I want to use? Let's make it teal. Okay. So amplitude. Remember, amplitude is the A value, the number in front of the sine. So the number in front of sine is 1/2. So that is our amplitude. So you know how the parent function was up 1 and down 1 above and below the midline? That's because the A value was a 1 there in front of that sine. When you don't see a number, you assume it to be a 1. Okay. Well, this one means that our amplitude is 1/2, so we're going to be 1/2 above and below that midline. Okay. The period we find by, remember, it was 2 pi over b. Well, the b value, so this is A, b is squeezed in right there. There is nothing in front of that parentheses, so what do we assume that to be, guys? That's right, a 1. I'm not going to write that in there. So this is really 2 pi over 1. So our period is 2 pi. Okay. Remember, the period is how long it takes to complete one cycle. The increments are the new thing that wasn't on the previous page. So you always take the period. So I'm going to put period, and you divide by 4. And that's how you find the increments. So the period was 2 pi, and we're dividing that by 4. So we get 2 pi over 4. And then we have to reduce that. So that becomes pi over 2. So my increments are in pi over 2. These are going to be important for finding what to label your x-axis as. Okay? This is where you're going to have to do a little bit of fraction math, and we'll get to that point. So we're going to come back to the increments. Let's find the rest of our list. The phase shift, I see x minus pi over 3. So remember, when it's minus, because that's how it is in standard form, that means that this plugged in was a positive value. So that means we're going to the right. So our phase shift is right pi over 3. Vertical shift is the plus d on the outside of the parentheses. Well, we don't have that. So that means that there is no vertical shift. There's none. Okay, so we found everything on our list. For all of these problems, you are always going to make this list. So there are 5 things on this list. You will be in the habit of writing these down every single time, hopefully, if you're doing it. And if you're watching this, I'm assuming that you're doing it. All right, so the next thing that we need to find are our start and stop. So remember on the previous page, we have our normal start, normal stop, and how to find the new start and stop for the problem that we have at hand. So we're going to be doing this part next. Okay, so I'm going to separate this here. And let's find our start first. So we find the start by taking the b times x minus c. That's this part. And we set it equal to 0. That's our normal start. So the b value is just a 1. So it's just, I don't need to write 1. So it's just x minus pi over 3 equals 0. And I didn't really need the parentheses there. So I just have to solve for x. So we would add pi over 3 to both sides. And we would get x equals pi over 3. Okay, so this is where we are going to start. This is important. Okay, in fact, I'm going to make this stand out. That's what highlighters are for, right? Okay, now let's work on our stop. Let's figure out, well, when do we stop this cycle? Okay, so we take the same thing, the b times x minus c, which is x minus pi over 3, and we set it equal to 2 pi, and we solve for x. Okay, so we're going to have to add pi over 3 to both sides. Okay, and I'm going to put the 2 pi over 1 because I'm going to need to get a common denominator. And since the pi over 3 has a 3 in the denominator, both denominators are going to need to be a 3. So I'm going to have to multiply the 2 pi over 1, top and bottom, by 3 so I can get that common denominator. So that would be 6 pi over 3 plus 1 pi over 3 equals 7 pi over 3. So we're going to stop at 7 pi over 3. Okay. All right, I didn't leave enough space for myself to do the increments part, but I will do it in pencil at the top here because I have some room there. So I need my start, my stop, and now my increments. The increments are pi over 2. So I'm starting at pi over 3. So this is how I'm going to do it. I'm going to use my pencil, and I'm just going to write up here in this little scratch paper area. I'm going to put 1 because this is my start. And my start was pi over 3. And now I'm going to add the increments. The increments were pi over 2. So I'm going to add pi over 2 to that. Okay. And I'm going to circle this pi over 3 because that's going to be one of the marks on my x-axis. Okay. So we need to get a common denominator. So the only thing in common between 3 and 2, well, to make them have something in common is to multiply them together. 3 times 2 is 6. So I need to make the denominator 6. So I'm going to multiply this one top and bottom by 2, and this one top and bottom by 3. So I will get, that will be 2 pi over 6 plus 3 pi over 6. 2 pi over 6 plus 3 pi over 6 is 5 pi over 6. And I'm going to circle it because this is my second point on the graph. Actually, let's not write that too. I don't want you guys to be confused there. Okay. So now I have 2 things that I can mark on the x-axis. Okay. But I have to keep adding pi over 2 until I get to my stop, until I reach 7 pi over 3. That's how you know when you're done. Okay. So let's add another pi over 2. Okay. But remember, we have to get a common denominator. And last time we had to get a denominator of 6. And this time we also have to get a common denominator of 6. So remember we converted pi over 2 by multiplying it top and bottom by 3. And it became a 3 pi over 6. So since 3 pi over 6 and pi over 2 are basically the same thing, instead of pi over 2 here, I'm going to write 3 pi over 6. Because it's the same thing. And then it saves me some room on my paper. Okay. So 5 pi over 6 plus 3 pi over 6 is 8 pi over 6. And that is reducible. So let's see, we can reduce out of 2. 8 divided by 2 is 4. 6 divided by 2 is 3. Now I have 4 pi over 3. Okay. Well, I haven't reached 7 pi over 3 yet, so I got to keep going. So I'm going to add another pi over 2. Okay. I'm going to save myself some room on the paper. So underneath this 8 pi over 6, I'm going to put 4 pi over 3 underneath it, and I'm going to circle it because that's the third mark on my x-axis. Over here, I'm going to keep this as 8 pi over 6 because I'm going to have to get a common denominator. And we already know that pi over 2, when we get it to have a common denominator of 6, is 3 pi over 6. So I'm going to erase that. So you guys see why I needed a pencil with an eraser that works also. Okay, so now I have common denominators and I didn't have to think much about it except for use my resources. So 8 pi over 6 plus 3 pi over 6, 8, 9, 10, 11 is 11 pi over 6. And I don't need to reduce that because there's nothing I can do to reduce it. So that is my next mark. So I have 1, 2, 3, 4 marks now that will be on the x-axis. I still have not reached 7 pi over 3. So I have to keep going. So I got to add another pi over 2, but it has to have a denominator of 6 because that's going to be the common denominator. So I'm really adding 3 pi over 6 again. Okay. 11 pi over 6 plus 3 pi over 6 is 14 pi over 6, which is reducible by 2. So 14 divided by 2 is 7, 6 divided by 2 is 3. So that is 7 pi over 3, and it looks familiar because that's our stop. Woohoo! Okay, so basically, moral of the story, when you are finding the increments for whatever problem you're working on with sine, it will always be 1, 2, 3, 4, 5 marks. It'll never be more than that. It'll never be less than that. Okay? So if you end up getting less or more, then something wrong happened. Okay? Maybe you messed up on the start and stop. Maybe you messed up on the fraction math. So try to narrow in on where you messed up if that happens. Okay? But you should always have 5 marks. All right, we are ready to graph this one. And the other 2 examples should go a lot faster after this one because now we've laid the groundwork, so now you guys kind of know what the process is. Okay, so I'm going to go to my graph paper here, and I'm going to use a dark pen, so I'm going to use black for this. This was example 1. And let's see, I want to make my graph fairly big, but the y-axis doesn't need to be huge, so I'm going to do it like that. And so what's nice about having graph paper is that you don't necessarily need a ruler. And you guys know that I suck at drawing straight lines, but when I have the lines there to guide me, I can do it a little bit better. And also when I'm sitting down, it makes me draw a little bit straighter. So that could be the key. Anyways, I hope you guys miss me as much as I miss you and all my quirkiness. But anyways, I miss you guys a lot. All right, here we go. So let's put our increments down. So we had pi over 3 and 5 pi over 6, 4 pi over 3, 11 pi over 6, 7 pi over 3. So Mrs. Garcia, we didn't need the negative side. We only have positive radians there. Yep, you're right. That's okay. So let's see. How do I want to space these out? Can I fit 5, 2, 3, 4, 5? 1, 2, 3, 4. Yeah. Every 2 lines I could space them out, make it look pretty. When you cram it all together, it's going to look funky and it's not going to look pretty. So it's nice when we spread things out a little bit. So my first one was the start, pi over 3, and then 5 pi over 6, and then 4 pi over 3, and then 11 pi over 6, and then our stop, 7 pi over 3. Okay, our x-axis is done. Now let's look at the y-axis. So let's let this be 1 unit and this be -1. But remember, our amplitude was 1/2. So let's also mark a half, positive half and a negative half on our y-axis. Okay? All right, we are good to go, guys. So let's go ahead and start plotting these. So when we graph the sine wave, all we have to remember is how it goes. When we do a cycle, if we look at the parent function, it starts on the midline and then it goes up down, down, up. Up, down, down, up. So that's the same pattern we're going to follow because the sine wave, that's how it goes. So our midline is still the x-axis because we didn't shift vertically. There was no vertical shift. So our midline, I'm always going to use a highlighter for that or a colored pen. That's easy to see. Okay, so that's my midline. I always like to graph that. You'll be happy that you do that later on for some of the other problems. So please, whatever I'm showing you to do, do it, okay? All right, so we know that the sine wave starts at the, well, normally the parent function started at 0, 0, but this one was shifted to the right, pi over 3. So it's going to start on the x-axis there, just like this one started on the x-axis at the origin, okay? And then it goes up, down, down, up. So at the next mark, it's going to go up a half and then back to the midline. And then at the next mark, it'll be down a half, which is right here, and then back up to the midline. And that is my full cycle. So I'm going to go up, down, down, up. And there's my sine wave. Isn't that so pretty? Isn't it so cool? Like you guys, we're graphing this. So feel accomplished if you are watching this video and you are giving it a shot and you're trying. First of all, proud of you. Second of all, this stuff can be so fun if you let yourselves enjoy it and be thankful that you have the ability to be able to learn this, So yeah. Anyways, it's beautiful. I'm so proud. Okay. I love these, as I'm sure you could tell. If you're not loving them, that's okay. Maybe you'll learn to love them over time, but they're really not that bad. You got to give them a shot. All right, number 2. We have y equals negative sine of x minus pi over 2 minus 1. So we first of all need to do our list. We have 5 things on that list. I'm going to try to squeeze all 5 in here without making them too small for you guys. So we have amplitude that we have to find, the period. I'm just going to put PER for period. Increments, I'm just going to put INCR for increments. Phase shift and vertical shift. And hey, I was able to fit all 5 on there. 1, 2, 3, 4, 5. Yeah. I was like, wait, is that 4? No, I didn't miscount. I'm seeing things. All right. So let's see, what color do I want to use? I think I want to use this pretty blue. All right, so the amplitude, remember, is the absolute value of A. If you don't remember, there it is, absolute value of A. It's just distance, and distance is always positive. Okay, so that's the absolute value of -1, which is just 1. So that means that this graph is going to be 1 unit above the midline and 1 unit below the midline when we do our wave. Okay, do the wave, do the wave. All right, the period is 2 pi over b. So 2 pi over, the b value is the number in front of the parentheses, and there is no number there. So that means it's a 1. So 2 pi over 1 is just 2 pi. Okay. The increments we find by taking the period, which is 2 pi, and divide by, do you guys remember what we divide by? If you said 4 out loud, you're right. Or even 4 in your head, because maybe you don't want to say it out loud. All right, and let's reduce that. That would be pi over 2. So we're going to be adding pi over 2 each time to find our increments. Okay. And phase shift, we're going to the right pi over 2, because it's x minus pi over 2. And then we have a vertical shift of going down 1. Okay. All right, so we have our list, and let's go ahead and find our start and stop. Now, before I get into the start and stop, I do want to point out something. Not a lot of other teachers do the whole increment thing. Everyone has their own way to graph these. I find that finding the increments is the easiest. It's the way that makes the most sense to me, and I've looked at a bunch of different ways because I was trying to look at maybe there was a better way to teach it to you guys, but I still think that this is the best way to do it. So if you go on YouTube, you'll see examples of how to graph the sine wave and cosine wave, and there are some people that do the same thing I do, and there are some people that do it a different way. So it's a personal preference type thing, and as you go up in math, you'll figure out what you like best. But this is what I learned in college, and this is what I continue to do even today because I feel like it's the easiest way to do it. So just know that I try to find the best way to approach these things for you guys, and so even though it does take a lot of steps, it's the best way that I think that you should do it, okay? All right, anyways, for the start, we take the b times x minus c, which in this problem, it's x minus pi over 2, and we set it equal to 0 because that's our normal start. And then for the stop, we do the same thing, x minus pi over 2, but we set it equal to our normal stop, which is 2 pi. This one's pretty easy. You add pi over 2 to both sides, x equals pi over 2. So we're starting at x equals pi over 2, which actually makes sense because we shifted to the right pi over 2. So instead of starting at 0, 0, now we're starting to the right, which is at pi over 2. Okay. Our normal stop, or for this problem, we're going to have to find by adding pi over 2 to both sides. And we're going to need to get a common denominator. Okay. So obviously the denominator is going to have to be a 2 since this is pi over 2. So the 2 pi over 1, I'm going to have to multiply top and bottom by 2. Okay. So that would become 4 pi over 2 plus 1 pi over 2 is 5 pi over 2. So this will be my stop for this problem. And I have some room right here, so I'll put my increment work, my fraction work in there. Okay? So when we're doing the fraction work, like I said, I like to use pencil, and we always start with our start with the start, which is pi over 2, and circle it because that's one of the marks that you're going to make on your x-axis. And then our increments are what we keep adding to find those marks. So our increments are in pi over 2, which is glorious because we have a common denominator right away. So the math here is pretty easy. So 1 pi over 2 plus 1 pi over 2 is 2 pi over 2, which I'm going to reduce it and write it below it. So the 2's will cancel, and that would just be a pi, and I'll circle it. So there's my second mark. Remember, how many marks are there going to be? 1, 2, 3, 4, 5. There will always be 5 marks, okay? So we have 2 of them. So now I need to add another pi over 2. So I want you to notice what I'm doing here. I'm going to use the unreduced version because it will have a common denominator with pi over 2. It saves me some work and extra writing. So 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. Okay, so there's my third mark. And then 3 pi over 2 plus 1 pi over 2. That's going to equal, I'll write it over here. It's going to equal 4 pi over 2, which reduces, because 2 goes into 4 twice, it reduces to 2 pi. So I have 1, 2, 3, 4 marks. I have one more mark, and this next time I add pi over 2 should get me to 5 pi over 2. So I'm going to use the unreduced version again. 4 pi over 2 plus 1 pi over 2 is indeed 5 pi over 2, and there's my 5th mark. So now I'm ready to graph this. Do you see how much faster that was this time? Not so shabby. Okay, so I'm going to go to my graph paper and pull out my black pen again. Got pens everywhere. All right. I don't have any negative marks. These are all positive radians, so I'm going to make sure that I take that into account in my graph. And for the y-axis, I do have a shift down 1, so I'm going to need more on the negative side. So I'm going to draw my positive side up here. So I have more room on the negative side of the y-axis. Okay. And my amplitude for this problem was just a 1, so I don't need halves on my graph this time. I just need 1s. So I'm going to have a positive 1 up here, and then -1, -2. Okay. All right, and then I'm going to do my marks. I like to space them out every 2 lines. 1, 2, 3, 4, 5. So I made mine a little bit too big, but that's okay. All right, so what are my marks? Goes pi over 2, pi, 3 pi over 2, 5 pi over 2, 2 pi. So pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. My start and stop. Okay, so now let's go ahead and graph. But the first thing that we should look at, I'm going to put a star next to it, is our vertical shift. The midline gets moved. Instead of being at the x-axis, it is now down 1 unit. So since we're going down a unit and we're normally up here on the x-axis, I have to go down a whole unit. So now my midline is over here, y equals -1. So I'm going to mark that with my highlighter. Okay, nice and bright so we can see it. Oops, focus. Okay, and where's my purple pen? It's hiding. And now let's get started. But I'm going to start this off using pencil. And you're going to see why in a second. There was another thing in here. That's a negative. Remember when we have like y equals -x squared? That means that the parabola is facing down. So that's what a negative does. It reflects. So we're going to have a reflection here across the midline. So I'm going to show you how to take care of that. So we're going to graph it pretending that there's no negative there, and then we're going to reflect it. And that's why the pencil comes in handy. Once you get the hang of it, you won't need to do this every time. But this is how, since we're learning this is how I like to start it off. And even after I've learned it, I like to do it this way because then it kind of eliminates me making a mistake. Okay, so we're starting at pi over 2, and sine starts on the midline at pi over 2. And then it goes up, down, down, up, remember? So then I have to go up a unit. So a whole unit puts me on the x-axis at pi. And then at 3 pi over 2, I'm back down to the midline. And then at 2 pi, I'm a unit below the midline because it goes up, down, down. And then I'm back up to the midline at 5 pi over 2. Okay, now don't graph the wave yet. Now we're going to reflect it. So at pi over 2, when I reflect across this line, it's on the line. So it's still going to be on the line. This point up here, as it gets reflected across the line, so it's 1 unit above it, now it's reflected to the other side, so now it's 1 unit below. So notice I'm using my pen now because this is the permanent part. The next point is on the midline, so when we reflect it, it's still on the midline. And then this point is a unit below the midline, so when I reflect it, it is that same distance above the midline. And then this point is on, so it didn't move. So basically, it reversed it. It goes down, up, down, instead of going up, down, down, up. I like to put arrows on mine. And there's our graph. Okay, so remember, this one was reflected. That's what that negative in the front means. All right, so that was number 2. So let's take a look at the last example here, number 3. Y equals 3 sine of 2x plus pi over 4 plus 1. Okay, so remember the warm-up that we did? I bet you already forgot about that. So the warm-up that we did had us factor out a number from a fraction. That's basically what we were practicing. So that comes up because our b value is hidden. Notice these x's were all just 1x, 1x. So that's what b was. It was just a 1. But now there's a 2 in front of the x. So that means the b is 2, and I have to factor that 2 out. Okay? So let's put an arrow to the 2 and put in our notes, factor out. Okay? All right, so next thing, All right, so we know that our A is 3, our B is the 2, we have our C is, we don't know what C is yet because we have to factor out the 2, but we know that D is a 1. So the reason why we have to factor out that 2 is because it's going to change this fraction. So pi over 4 is not our phase shift. Something else is, and we need to see what that is. So y equals 3 sine, all right, we're going to factor out that 2 plus 1. So 2x divided by 2 is x plus, because it's positive divided by positive, pi over 4 divided by 2. Remember, that's the same as pi over 4 times 1/2. Dividing fractions easy as pi, flip the second and multiply. So the reciprocal of a 2 is 1/2. So pi over 4 times 1/2 is pi over 8. Guys, you need to keep the volume down, please. Okay, so it's x plus pi over 8. So that tells me that the C is a phase shift to the left because it's plus pi over 8. So if we don't do that, our phase shift will be wrong. And you need to be able to identify the phase shift correctly. All right, let's do our list. So we need the amplitude, we need the period, increments, the phase shift, and the vertical shift. Okay, so the amplitude this time is a 3. Our period is 2 pi over b, but this time the b value is a 2. Okay, so the 2's cancel, so our period this time is a pi. The increments are, you take the period, which is pi, and you divide by 4, so those are my increments. The phase shift is, it's plus, so it's left, pi over 8. And our vertical shift is up 1. Okay. So we have to pay attention to some things. Since our amplitude is 3 and we shifted up 1, I'm going to need to make sure I have enough units on my y-axis. So my y-axis is going to need to be a little bit taller on the positive side than it was on the other 2 graphs that we did. And since we're shifting to the left pi over 8, that means we're going to be on the negative side of the x-axis this time, okay? All right, so let's take care of our start and stop. This is where we take the b times x minus c, which is 2 times x plus pi over 8, and we set it equal to 0. And then for the stop, we do the same thing, 2 times x plus pi over 8, but we set it equal to 2 pi. Okay, so when we are solving for this, you don't want to distribute the 2. It's way easier if you just divide both sides by 2, because what's 0 divided by anything, guys? That's right, it's 0. So I have x plus pi over 8 equals 0. And then I would subtract pi over 8 on both sides. So on the other side, it would be negative pi over 8. And this is where we are starting. See, didn't I tell you on the negative side? Okay, for the other one, let's follow the same steps. We would need to divide both sides by 2. And 2's cancel on both sides. So I have x plus pi over 8 equals pi. Okay. Subtract pi over 8 from both sides, and I would get, so I would subtract pi over 8, and I'm going to write minus pi over 8 to the right, because I like them horizontally when I'm trying to get common denominators. All right, so obviously the denominator needs to be an 8, so I need to multiply top and bottom by 8. So I will have 8 pi over 8 minus 1 pi over 8. So that would give me 7 pi over 8. Okay, so I have my start and I have my stop. All right, let's find the increments. So remember, we are starting with negative pi over 8. And I like to circle that to show that that's one of my marks on the x-axis. And the increments were in pi over 4, so I have to add pi over 4. Okay, so I'm going to have to get a common denominator. So obviously it's going to have to be an 8. So I'm going to have to multiply this one top and bottom by 2. So negative 1 pi over 8 plus 2 pi over 8 is pi over 8. And there's my second mark. Okay. And then the third one, I have to add another pi over 4. But I'm going to have to get a common denominator again, and I know that I'm going to have to multiply top and bottom by 2, so I know that I'm adding 2 pi over 8, because that's the same thing as pi over 4. So 1 pi over 8 plus 2 pi over 8 equals 3 pi over 8. I'm going to circle that. It's my third mark. I'm still not at 7 pi over 8, but I'm definitely getting closer. So now let's add another pi over 4, which is the same thing as 2 pi over 8, so that we have that common denominator. 3 pi over 8 plus 2 pi over 8 is 5 pi over 8. Getting closer. Circle it, and that's my fourth mark. And then let's go ahead and add another 2 pi over 8, and that's going to get us there. 7 pi over 8, and circle it. So we have our 5 marks. We are ready to graph. Excuse me. My throat's getting dry because this is the most talking I have done in quite some time. Where did my black pen go? Oh, there it is. It's blending in. Okay. So remember our amplitude was 3 and we shifted up 1. So if we're thinking of the x-axis and I'm shifting up 1, but then the amplitude has to be 3, that means I need 4 above the x-axis, I think. Or at least it's better to overestimate than underestimate, that is for sure. So let's say that this is 4, 3, 2, 1, and then this would be 0. So here's where my x-axis would be. This is how I think of doing my graphs. Okay, this would be -1. All right, and I need my marks. And what were they? Oh, I had one on the negative side. So we had negative pi over 8. And then we had pi over 8. And then 3 pi over 8. And then 5 pi over 8. And then 7 pi over 8. So I still have my 5 marks. Now this one, I should have made it a little bit closer. I should have put it at this mark instead of that one. So this part of the wave is going to look a little wider, but that's okay. It's just a sketch, so it doesn't have to be perfect, but these are the things that I expect to be labeled on your graphs. Okay. All right, so here we go. The midline, remember, it got moved. We shifted up 1. So I'm going to grab my highlighter. We're normally on the x-axis, but we got shifted up 1, so my midline is up here now. Okay. All right, so, and where is our start? It is, oh, that's not the pen I was using. It was at negative pi over 8, so we're going to start on the midline there. Okay, and then remember our amplitude was 3. So when we go to the next mark, we're going to be 3 units above the midline at that mark. So the next mark is pi over 8, and I'm going to be 3 units above that. So 1, 2, 3. Okay, and then at the next mark, I'm back down to the midline. And then at the next mark, I am 3 units below the midline. So 1, 2, 3 would be down here. And then at the next mark, I'm back up to the midline. Okay, so we're going up, down, down, up. Isn't that so cool? So you notice that was wider. Like I said, it might be, but it still looks good. It's not bad. So there we go. So that is how you graph the sine wave. So your homework is these problems right here. There's 8 of them. And I will go over these, but I do want you guys to try them on your own. Remember to do the list of 5 things every single time. Find your start and stop. Find your 5 marks, your increments, and then you're good to graph. okay? Take into account if there's a vertical shift because that moves the midline up or down. Take into account the amplitude because that tells you how far above and below the midline you're going to be graphing that wave. And remember, problems like 7 and 8, you're going to need to factor out that number in front of the x, just like the warm-up, okay? So make sure that you're not going to be able to cram that in this space right here, so you have to do this on a separate sheet of paper. Obviously, graph paper is the best because it's the easiest to manipulate with, but if you don't have that, please make sure you use a ruler, and line paper would be the next best thing because at least there's already lines on there. And yeah, have a good one, you guys. Sorry this video is so long, but I just wanted to be very thorough with everything. I miss you guys. Have a good one. I'll see you in my next video.